right. Hi, everybody. So there's some pieces of this that are very similar to Malachi on the Kansas City side, but there are some distinctions which I'll point out. So I'm Ashley Sadowski. I'm the Director of Building Energy Exchange Kansas City, as Malachi said, started about 3.5 years ago. We are a good counterpoint to each other because we represent two sides of the AE industry. As well as provide a lot of guidance of on-the-ground work that we've done both in St. Louis and Kansas City and other regions of the country. So we try to come at it from the reality of what happens on the ground when you're in a design and construction project. So as Malachi talked about, there is a number of other national hubs that we work with, including the Building Innovation Hub in DC, Building Energy Exchange in New York, which is the OG, the first building hub in the country that has been around for about 14, 15 years now, as well as recently the Building Energy Resource Hub in Chicago. So we have these partners across the country with a shared vision around zero barriers to net zero energy. So finding a way to remove any obstacles that prevent building owners, maintenance folks, everyone in that real estate ecosystem from building and designing to the highest level of performance possible. And as Mary will talk about, we also work a lot with our regional partners, including the Mid-America Regional Council, which is where I'm housed. That's our local metropolitan planning organization, as well as Climate Action KC. A lot of the work that we did early on came out of a climate initiative, which recognized that 63% of our greenhouse gas emissions in the region were attributed to buildings, both residential and commercial. So that really started the conversation of where we could affect that part of the problem through the lens of real estate. So because we come out of a climate space, we do talk a lot about net zero, and I thought it might be helpful to understand what net zero means in the context of buildings. There's a lot of folks who have a lot of different definitions, and my feeling on this, and I hope this works for you as well, is we got to keep it simple. We don't need to worry too much about the nuances right now. We just need to make sure we're being really pragmatic on how we get there. So the first thing is use less. Really simple stuff here. So building reuse whenever possible, right sizing your buildings. We're seeing that in the office market for sure, as people realize we actually didn't need this much space, as people consider hybrid work environments and other ways to work. So you might want to think about right sizing your space in the context of that, as well as your ability to reduce your energy load at the same time. Reducing waste. So this is particularly important when you're doing a major renovation project. How can you reuse materials? How can you recycle those materials and reduce waste? The construction industry has come a long way in that space over the last few years. There is a lot of new technologies and recycling abilities to reduce your waste. So definitely if you have a large project, think about that, because they're moving as we see more lead projects and other projects that demand that level of high diversion rate, that's becoming more commonplace. And then just the basics, local durable materials. We don't want to put materials in buildings that have a short life cycle and we have to rinse and repeat on capital improvements all the time. The second is be efficient. So this includes passive envelopes. So this is high performance building envelopes that allow you to stay heated and cool for long periods of time without the need for excessive energy demand. This is especially important in times when we're thinking about severe weather, loss of power, how long can people stay in a building and be safe and comfortable. But even in the times when we're not dealing with those extremes that are becoming more commonplace, we also want to think about what is the minimum we have to keep people safe and comfortable without having to turn that AC on or turn the heat on, particularly in those spring and fall months. So HVAC systems, making sure those are operating as efficiently as possible. Some folks, due to a lot of the things that Malachi mentioned in terms of maintenance, tend to set it and forget it and not look back and see if it's optimized to the performance, especially as you think about changes in patterns of use, how people are utilizing the building differently. If you have half of your staff coming in compared to 100%, that's a completely different cooling load. So just thinking about those things are really important. And then transitioning to electric wherever possible. That's really to optimize your ability to connect to renewable power. So renewables become a lot more financially feasible as your demand lines up with electric usage. And then lastly, offset. So offset is just touching on, you tried everything you could in terms of reducing your demand, making it as efficient as possible. Everything that's left is offset. So that's using renewable power wherever possible to make sure that you have the cleanest form, either on-site or off-site. And then what is probably not talked about enough is carbon sequestration, particularly in the category of on-site carbon sequestration. I like to think of carbon sequestration as a fancy way of saying green space, trees, nature, bringing that into the site actually has a direct impact on your carbon footprint. And as you can see, it can actually be a very nice feature as a part of your building. And so I kind of touched on this already, but all of these come with a number of co-benefits. So whether that's as saving on construction and operating costs, preserving historic charm by using existing buildings, preserving existing neighborhoods, lowering energy bills, more functional and comfortable spaces, healthier indoor air quality is a big one, natural beauty and increasing productivity, all things that Malachi and I spread the word on is in addition to all the things that benefit the building itself. There's a lot of people-centered components to this. So I'm going to touch a little bit in more detail on what the path to net zero looks like in terms of existing buildings. And some of this will overlap with what Malachi said on the energy audit side, but I'm going to go a little bit more in detail, putting on my recovery architect hat and talking a little bit about the different components that go into what makes up an energy audit and what are some of the building blocks that come with that audit. So energy audit, step one. So as we talked about earlier, before you really get into the idea of planning for a project, you really want to take a step back, maybe even expand the scope of your search. So as an architect, I oftentimes have people come to me and say, I have this project, it's over in this wing of the building, and this is what we're doing. And really, the approach should be, yes, that all matters and that's important, but can we zoom out and can we think about what else in the building needs to be considered? Because if you have major energy savings that's living on the other side of the building, that might be important to know and important to address before you think about just one particular capital improvement project. So there's a couple steps to an energy audit. The first is ASHRAE level 1. So ASHRAE level 1 audit, I sort of equate it to getting a physical. So it's not going to be an in-depth look at your energy usage, but it will get to the big glaring pieces of it. So everything from interviewing key personnel to reviewing your utility bills, walking through the site briefly to understand if there's any glaring issues that they see right away that they can point to. Lighting upgrades is oftentimes a common one that's really easy to detect. And then setting a baseline for current performance. So this is where you, as we talked about earlier, benchmark your building, you're identifying what is the basic performance that we're dealing with today so that we can know what we're going to grow from there. And so, like I said, this is not necessarily something that will give you the full picture, but let's say you're looking at an entire portfolio of buildings across a campus, like where we are today. It might be a way of identifying which projects should be priority. So you might identify, okay, there's some real low-hanging fruit that's happening in building B and in building D. Those are the things we're going to address first, and then we'll look at some of the other places for more in-depth energy analysis. Okay, so the next level as I alluded to, was an ASHRAE level 2. So an ASHRAE level 2 builds on what the level 1 analysis does. This, kind of builds up to more data. Building personnel are interviewed in more depth. It gives insights and it really defines project goals and the scope of the project. And the other important component is the financial analysis. So it's going to identify what are those returns on investment based on those different scopes of work, which allows a building owner or a maintenance official to be able to look through that and decide which piece is the most important to them. You can go deeper into an ASHRAE level 3. That's if you have a major project and you really want to make sure your investment is sound, that you feel like you need that extra level of analysis. That's certainly possible. But for most buildings, an ASHRAE level 2 will get you pretty far. Okay, so this is my Oprah moment. Everybody gets a free audit. So some of you, because we're on an MU's campus, may be aware of the program that Dr. Sanjeev Khanna runs, which is the Midwest IAC Industrial Assessment Center. They have historically provided ASHRAE level 2 audits for industrial buildings for some time and have been very successful at saving a significant amount of funding for building owners. They recently have started opening that up to commercial buildings. So if you have a commercial building or you're aware of a commercial building that you think could use an energy audit, feel free to check this out. I put the convenient QR code, which will take you directly to their page. It's a very simple application. You can reach out to him directly as well if you have any questions, but I just like to promote this as much as possible. He's not getting a ton of reception in Kansas City, though he is getting more in St. Louis. So I'm in the process of trying to get the word out. This really is, as he says, the closest to a free lunch. So if you're looking to do a building project and the energy audit initial cost seems a little bit daunting and you're not kind of used to this process, this would be a great way to start. Okay, so I'm going to talk a little bit about what might be in that energy audit, and I can't necessarily dwell on every component of the audit, but I'm going to start by talking about what are a couple low-hanging fruit that are likely to be in that audit, particularly if you have a lot of deferred maintenance in the project that you're looking at, as well as building envelope pieces that we talk a lot about mechanical in the retrofit space, and maybe just selfishly as an architect, I think it's always important to think about your building envelope. So I'm going to talk about that today. So first and foremost, lighting retrofits. A lot of folks at this point are aware of lighting retrofits. I think what's really important to note is if you have a very small to no budget, lighting retrofits is still something you should consider because of the high return on investment. And also because a lot of our utility companies, particularly as we look in Ameren and Evergy territory, have rebates for all of those different kinds of lighting upgrades. So it's really a no-brainer to start there and make sure that you not only think about upgrading your lighting, but also think about upgrading your controls, think about sensors, all of those things, because they can all make a huge difference on your usage. The second low-hanging fruit is weather sealing. So you can see this image you can do through an infrared camera. There's a lot of really easy technology that will start to identify places where you're missing insulation, where windows are not sealed properly, things that could take very little cost to fix and have a tremendous amount of impact. So that's kind of a first step as well, is check your lighting, check you don't have any leaks, and then you can start investigating some more intense processes in your building envelope. Okay, so roof insulation. So roof insulation is a big one. Oftentimes this comes and coincides with a roof project. So a lot of people are thinking, my roof's leaking, I need to get it repaired. I just had a conversation yesterday with someone about this as the roof was leaking next to us. This is a great time to think about putting more insulation in the roof as you're doing that project. So there's a few different ways to go about that. You certainly would want to have an architect and someone involved in the project to make sure that it's detailed correctly. Anytime you go to insulate your building envelope, you want to make sure that you're understanding kind of any repercussions in terms of moisture. but that is going to make a huge difference. And particularly if you're thinking about solar and doing rooftop solar, it's also a great time to prepare for that as well. You can think about how that solar would integrate into the roof, if it's a ballasted system, how it's connected, where it's located, if there's any HVAC or rooftop units that are being moved around. This is all a great time to coordinate that and figure that out at the same time. So oftentimes folks are thinking about the leak that's coming through, but it's like the perfect time to make a capital improvement that coincides with fixing the basic issues that you need for a roof to do. Wall insulation, so nothing terribly revolutionary here, but a lot of times people are thinking about insulating their walls as they have major renovation projects happening. That's certainly a good time to do wall insulation on the inside. There is quite a bit of movement happening in the exterior wall insulation space, particularly as people think about recladding a building. So they may be thinking, I'm thinking a university campus, you might have a 50-year-old building that has a certain look and feel, and you want to brighten it up and you want to put some new facade on it. That's a really easy time to integrate some good insulation on the outside and have a continuous barrier of insulation across the building. So we're seeing a lot of new products come out. This is a product from Rockwell that's essentially a rain screen system with the insulation behind. So a lot of these products are really fitting the retrofit market in a way that we haven't seen before. Okay, so windows. So there's a few factors with evaluating how well a window performs. If you're considering putting new windows in, if you're looking at how maybe you have a newer building and you're trying to figure out how well they're performing, there's a few different factors here. So one is the U factor. So the lower that value is, the better. That's how quickly heat is conducted through the windows. So that's a pretty easy, straightforward way to assess it. We'll see this table on the side. Oftentimes, if you're seeing a window get installed, it'll have a sticker that looks just like that, and that'll tell you the performance of the windows. Oftentimes, you have to leave that sticker on until the inspectors come because they want to make sure that your energy performance is meeting what was designed. And so they'll look and see, okay, your U factor is meeting the requirements of the energy code. They'll also look at your solar heat gain coefficient. The solar heat gain coefficient is a little bit more nuanced because depending on the orientation of your building, you might want to change that up. So for example, south-facing windows, you might want to higher solar heat gain coefficient, and you might want to increase your ability to get in sunlight, get in heat into the building, particularly in cold weather. Whereas on the west facing, you would want that to be as low as possible because that's where you get excessive heat gain throughout the year, particularly in our climate. And then lastly, pretty straightforward, but with air leakage, the lower the number, the better for that. And so, like I said, I highlighted a few of the building blocks for how a retrofit project might work, some of the things that might come up in an audit. But there are a number of other things that you could do, including a number of mechanical solutions. Again, another QR code. If you're interested in learning about each of those different building blocks, you can go to our website. It'll talk about all of the different ways that you might improve the building. These are what are called technical primers. We try to make it pretty easy for folks who are just getting into the conversation. They're all about 4 pages long. Cost-benefit analysis of all these different technologies just gives you a very high-level understanding of why you might want to do that project. Okay, next steps. So this is my ask to the audience. We are in the process of designing a case study library that will feature a number of building projects throughout the region. This could be the Midwest region if you don't operate in the Kansas City region, but we're looking for projects within the proximity of the Midwest to everything from energy retrofits, so any of the things I just named. So if you have done some project where you had some windows that were replaced and you were really happy with the results and how much more comfortable those occupants became that have those window spots, or if you have an HVAC that you replaced and you're really happy with the fact that your energy bills have gone down. Those are simple technology fixes that we believe could be of use to other folks who are just trying to figure out how to get started in the energy efficiency space. All the way up to high performance design. If you did a major retrofit project, if you did a LEED certified building, all of those things are important, and we want to hear about what results came out of that. Or if you've done any on-site renewable projects. So that is my ask to you. We appreciate it's a very simple form. You don't have to provide a ton of information. We just want to know that you're out there and you're doing that work, and we can certainly follow up with you to get more detail. There's a couple of reasons that I would ask. The obvious one is that this allows us to build out a library so that we can all learn from each other. The second is that, and I'm not really wearing that hat today, but a lot of the work that I do is working with our local agencies on federal funding. And the more that I know about projects that are happening out there, the more we can connect them to those federal funds, specifically the Greenhouse Gas Reduction Fund, which is a large funding stream that is coming out of the EPA right now. So it's good to learn from each other, but it's also good to learn what the new financing and funding options are. So please connect with us through our website and share your projects. And that's all I have. And there's my email.